happy to introduce the next speaker, Johannes Hinkeldien from the Technical University of Hamburg. So from Industry 4.0, we remain in the real world setting. Now it's going to be about supply chain management and logistics. So thank you so much.
Thanks a lot for inviting me. I'm Johannes Hinkeldien from the Hamburg University of Technology, and I'm coming from a logistics background. So we are working for the Institute for Technical Logistics, so we're logistics engineers, but not computer scientists. So, and this paper is about our journey and our first attempts how we can apply blockchain to logistics supply chain management, and especially about all the flaws and the faults and the mistakes which we made trying to implement a prototype. So if you look into supply chain management and into logistics, blockchain is a very, very popular topic. And this is a survey which has been conducted by one of the institutes from our university, where they ask companies, logistics companies, where they see potential for applying blockchain and for which purpose. And especially they think that's very, very promising for reducing bureaucracy and for operating Internet of Things devices. So if we think about Internet of Things, we still have the vision which also goes along with Industry 4.0, that we, in a way, can connect all the devices, all the machines, all the orders, all the parcels, all the parts across the whole value chain into one network. So it's about collecting data in the fabric, doing the production, tracking positions of trucks and parcels, monitoring conditions, and the identifying of goods during the customs process, and many, many more. So how can we use blockchain in order to support this Internet of Things process, and how we can use it over there? And in order to do that, because we are logistics engineers, we were thinking about a practical solution and something, how we can really demonstrate how blockchain works so that one can touch and one can feel how it is. And so we did something really, really simple. So we used a conventional storage container, which you can see here on the left side, which is just used throughout warehouses to store whatever kinds of parts or products. And we were thinking about, hey, how can we get this storage container onto the blockchain? And this was already quite difficult because we were searching for potential solutions for containers which are able to determine its content and to broadcast it somehow over a network into some kind of computer. And this was already quite difficult because we only found two prototypes which use some kind of infrared sensors, which were not that very reliable. So in order to do that, we decided to enhance this really just conventional storage container type with putting a weighting device under that. So that's basically what you can see here on the right side. These are just weight sensors. It's, the technical term is strain gauge, but basically these are weight sensors, and these weight sensors are then using an operational amplifier. They are connected to a small IoT board. It was an Arduino board in the first step, which was a very, very naive idea, because then we just really, really quickly found out that this Arduino board does not have sufficient computation power and storage in order to run any kind of Ethereum like client or something. So in order to get this thing running, we added a Raspberry Pi to this Arduino board in order to get it somehow onto the blockchain. And we then decided we wanted to try to model some kind of, I would call it a decentral marketplace. So the basic idea was just something, let's imagine we have got several of these containers. So we have got a container on a customer warehouse, and this container is able to determine its weight, or the weight of its content. And because I know the average weight of every part which is inside, I know how many parts are inside. And if the number of parts or the weight of the parts falls below a certain threshold, this container should be able to order new parts from another container which stands at a warehouse at some kind of a supplying company. And this is basically what we did. So first of all, we used the Whisper protocol on Ethereum over there to post a request to the container, and so that this one could get a quotation. So it could be one supplier, it could be several suppliers, and based on the quotation, the buying container, as we call it, accepts the quotation and puts an order onto the blockchain. This order is then confirmed by the supplying container, the goods are delivered, and the order receipt is also stored on the blockchain. Then the payment is put into a multi-signature wallet, which then is transferred to the supplier. However, you can already see that there could be some kind of flaw, because what happens, let's imagine you would buy screws using this smart contract. What happens if the quality of the screws does not comply with your specification? So in this case, this is the reason why we use the multi-signature wallet over here. We need some kind of trustee. So we need a third person somehow in order to overcome this breach between virtuality and reality. Because who is able to determine if the quality is correct? And even who is capable of determining if there's really screws inside the container, not just stones or something like that. So in a way, we need some kind of trustee, some kind of person which can mediate in the case of conflict. And so this is the architecture which we used in order to build this prototype, which was just really a learning project for us. So we have got the container, and the container is then connected to a back end on a server, which could be some kind of ERP system or something like that, which is also connected to the Ethereum node. And over this Ethereum node, it communicates with the smart contract and the multi-sig wallets which are stored on the Ethereum blockchain. So what did we learn from that? Because we were really greenhorns when we started with this project, and we really wanted to see how this works in logistics and how it can practically work in logistics. So first of all, we had several problems using the right IoT hardware. Because IoT hardware, which we used, first of all, did not have sufficient power. And the second one, there's also a question of being economical. Because if you have a warehouse manager and you tell them that the container, which usually costs just a few cents, now costs, together with the network and all the sensors and devices and everything which you want to automate, it costs about $50 or $60. Nobody would do that. Because logistics is a very cost-driven industry. And we also need some tamper-proof hardware to identify our goods. Because how can we know that we really have delivered the right goods? So there are already some ideas, which maybe you've heard about the crypto anchors, which has been developed from IBM so far, which should in a way be able to identify that it's really the right good, the right product which you have. But this is something really we have to do some research on. Then also for the software, we found out that even the light clients from Ethereum just overstrain the less powerful IoT hardware, as well as the cryptographic chain from blockchain to sensor has been incomplete still, at least to my knowledge. And we still need some research on the platform-owned protocols, which has to be further developed. We use Whisper in this case, but we have also to make decisions on which, where we want to store our data. When do we want to store our data, on-chain or off-chain? And finally, this is something probably all of you know already, that we have got the security of smart contracts, which has to be, in a way, somewhere formally verified in order to prevent the compromising of smart contracts. Furthermore, The role of intermediaries in logistics is still a bit unclear because we have this, as I call it, the breach between real and virtual world, which still, in a way, needs some intermediaries. Because if I want to make business with someone, there are so many cases, especially in logistics, which can occur. How we can deal with that? So I don't know if we really can program all the logic and everything into a smart contract, or if we still need some intermediaries. But if we need some further intermediaries, who can these intermediaries be? Who is this trustee I'm talking about? What is the requirement of a trustee? What's the rights? What's the duties? Then scalability. If we think about this, the throughput of Ethereum, we see that the throughput of Ethereum is, at least of the whole Ethereum chain, is still not sufficient for running or operating a small distribution center, because you have so many more transactions, and if you want to put all the transactions on the blockchain, it will be difficult. However, there are already scalability solutions which have been discussed and which have been also implemented, but this is something which has to be tested and which has to be evaluated as well. And finally, there's also the question, how do we deal with interoperability? If we have different supply chains, we might have used different blockchain solutions. How we can deal with that if I'm a supplier and I have got several customers, and several customers want to work with me on several blockchains, it might get very difficult for me, because I have to deal with all these different blockchains and in a way to integrate it into my IT systems, which is then something which really has to be found a solution for. The next steps. We are still in the very, very beginning. This is just the very, very first prototype. We would like to try other platforms and other blockchains to see if this works better. For example, IOTA or Hyperledger Fabric and Sawtooth are on our list at the moment. We are currently thinking about developing IoT hardware for blockchain applications. This is something which has to do with low energy electronics, which even has sufficient storage and computing power. So having some special, let's call it, boards for IoT devices using for blockchain. And it's also important that we think about how to expand the layer of trust from blockchain onto the sensor as well. And finally, still we have to think about an intermediary application for logistics. So how can this trustee be integrated into the blockchain, and how can we deal with that? And therefore, we need some concepts and some solutions as well. So wrapping everything up, I think my talk and my paper has probably more questions than answers, but this is something which is probably also quite in common at the moment, but I'm very excited to see how it goes further. Thank you very much, and I'm looking forward to your questions.
Thank you, Johannes. Okay, we have a question here.
Thanks. Have you also thought about data privacy? I mean, if all the orders are on the blockchain?
Yeah, that's definitely something we have to think about as well, especially with the new data privacy regulations in Europe, which we are currently facing. Nevertheless, it is still a topic to be covered as well, but we haven't included this yet as well.
Any further? Yeah, here, question.
Thanks for presentation, very interesting. And my question is, you mentioned in your system, in the beginning of the presentation, about specification of the service, what they provide to other system. How you specify it? I mean, what it really looks like? The file with description of what?
You're referring to which slide are you referring to?
I think it will be something like fifth slide.
This
Yes,
one?
yes,
Yeah.
that.
And
Oh,
you're referring to which service is that?
I mean, it's what you putting in the request and quotation. How you describe the what goods should be delivered or what service?
Okay.
Yeah.
Yeah, it should be. This must be something which is probably stored in the ERP system already, so that you have got some specification like you're ordering some kind of goods with a usual article code, and you probably have got, let's say, you are willing some particular price to pay, which you put into the request, and then the supplier has been able to answer. But this is still quite open with what you put into the request. But it's in a way you need some kind of standard format to.
And how you match it?
Pardon me?
How you match it?
At the moment, we have still only tried this with screws. So we have particular screws and screws and engineering are normed. So you have just a very you can describe them very accurately, and you can put them into the message then.
Thank you very much. I have a bit of a more philosophical question maybe. So you said you're working currently on the Ethereum blockchain. The Ethereum blockchain is an open, decentralized blockchain where anybody can join and leave at any time. But now you're also exploring like other types of blockchains such as Hyperledger, Fabric. What's the rationale behind that? Because typically Hyperledger is being run as a private blockchain. So why would you consider going this way?
I think that this is for two reasons. The first reason is the scalability, which at least Hyperledger and IOTA promise to deliver, that they are having a higher scalability, higher throughput than Ethereum has at the moment, which is important for, let's say, distribution centers, logistical applications. And the other one is that I think that a lot of companies, a lot of logistics companies are more looking into the private blockchain sector at the moment than they're looking into the public blockchain sector at the moment. This is at least my experience, what I hear from industry. And in a way, I think we will need some prototypes on a comparable basis, where we can compare public blockchains and private blockchains as well.
Okay, I see. I mean, in particular regarding scalability, you mentioned there are a few solutions on Ethereum that might solve your problem, maybe in the next months or year to come. Privacy is still a major issue, I agree. Yeah. Okay, great. Thank you so much.
Thank you.